Hello, everyone. Welcome to Brain Blitz Audios. In today's episode of Cbse board exam, we'll be dealing with previous year questions of mathematics in Cbse board exams. Today's chapter that we'll be dealing with is vector algebra. This is the 10th chapter in the grade 12 syllabus for Cbse. Now, we've made a previous episode on vector algebra, and if you want to see that again, then please don't hesitate to click the link in the description down below. With that said, let's move on to our first question of this webisode. If A bar is I cap plus 2j cap minus k cap, and B bar is 3i cap plus j cap minus 5k cap, then find a unit vector in the direction of A bar minus B bar. So now, in these questions, finding the unit vector is easy. You just need to divide the vector by the modulus of that vector. But what do we do when we need to find a vector? That is the main part of this question. So over here, we're given two vectors. A bar is equal to I cap plus 2j cap minus k cap, and B bar is equal to 3i cap plus j cap minus 5k cap. The first thing we need to do is find out A bar minus B bar. And so we subtract vector B from vector A. So it'll be I cap plus 2j cap minus k cap. Put this vector in a bracket and then put a minus sign and then write the second vector, 3i cap plus j cap minus 5k cap. Now we distribute it into each of the components, I, j, and k. So it'll be 1 minus 3 and then I cap plus 2 minus 1 and then j cap plus minus 1 minus of minus 5 becomes plus 5 k cap. So we'll be getting minus 2i cap plus j cap plus 4k cap. This will be the value of A bar minus B bar, the required vector. And since we need to find the unit vector of A bar minus B bar, we need to find out the modulus of A bar minus B bar. And that should be simple, right? Modulus of A bar minus B bar will be equal to minus 2 the whole square plus 1 the whole square plus 4 the whole square and a big root. So minus 2 square is equal to 2 square, which is equal to 4, plus 1 square is 1, plus 4 square is 16. Therefore, we're getting root 21 as the modulus of the vector A bar minus B bar. Now we find the unit vector. So unit vector along A bar minus B bar, we write that as A bar minus B bar divided by modulus of A bar minus B bar. So A bar minus B bar is minus 2i plus j plus 4k and divided by the modulus, which is root 21. But in order to completely find out the unit vector and to completely represent it, let's distribute this denominator to each of the terms. So what I mean is we can write this as minus 2 by root 21 I cap plus 1 by root 21 j cap plus 4 by root 21 k cap. This is the value of the unit vector. And that ends our first question. Let's look at our second question. Find a vector of magnitude 5 units and parallel to the resultant of A and B. So we have A bar vector A is equal to 2i plus 3j minus k. Vector B is equal to I minus 2j plus k. And now we need to find out the resultant. The term resultant should tell you that the vector we're looking for is a bar plus b bar. And so a bar plus b bar is equal to 2i plus 3j minus k. That is in one bracket. And then plus the other bracket, which houses the other vector, I minus 2j plus k. Now we'll reduce it to its components. So 2 plus 1 I plus 3 minus 2 j plus minus 1 plus 1 k. So that will give you 3i plus j plus 0k. And the reason why we write 0k is we need to represent it in the standard form. So this is the vector a bar plus b bar. Now we need to find out the modulus so that then we can find out the unit vector, which is parallel to a bar plus b bar. And once we find that unit vector, we just multiply by the magnitude 5 units in order to get the required vector. So modulus of a bar plus b bar, that'll be equal to 3 square plus 1 square plus 0 square. And then that will be 9 plus 1, which the whole root, which is equal to root 10. So the value of mod a vector a plus vector b is root 10. Now let's find out the unit vector. Unit vector parallel to a bar plus b bar. So that is a bar plus b bar divided by modulus of a bar plus b bar. So that will be equal to 3i plus j plus 0k divided by root 10. That gives you 3 by root 10i plus 1 by root 10j plus 0 by root 10k. Again, the reason why we're writing k is just to keep it in standard form. Otherwise, 0 by root 10 can be written as 0, so there will be no k component. So this is the unit vector. Now, our required vector along a bar plus b bar, so the required vector which is parallel to a bar plus b bar is magnitude times unit vector. So that's how you represent a vector. A vector is the product of its magnitude and its unit vector. And so using that, we can find out our required vector. The magnitude is 5 units and the unit vector is 3 by root 10i plus 1 by root 10j plus 0 by root 10k. And so we can just multiply on all the terms. So we'll get 15 by root 10i plus 1 plus 5 by root 10j plus 0 by root 10k. Again, 5 times 0 is 0. And so this is the answer to our question to find a vector that is parallel to the resultant of vectors a and b and having magnitude 5 units. Next question. Now we have vectors a, b, and c given. We need to find a vector of magnitude 6 units, which is parallel to the vector 2a bar minus b bar plus 3c bar. So 2 times vector a minus vector b plus 3 times vector c. First things first, let's write our vectors. A bar is, the vector a is I cap plus j cap plus k cap. Vector b is 4i cap minus 2j cap plus 3k cap. And vector c is I cap minus 2j cap plus k cap. Now let's find the vector to which our required vector is parallel. In this case, that vector is 2a, 2 into vector a minus vector b plus 3 into vector c. So that'll be 2 times right vector a, I cap plus j cap plus k cap, minus vector b is 4i cap minus 2j cap plus 3k cap, plus 3 times vector c is I cap minus 2j cap plus k cap. Now let's multiply. So we get 2I cap plus 2j cap plus 2k cap minus 4I cap minus 2j cap plus 3k cap plus 3 into whatever, 3 into the vector. So that gives you 3I cap minus 6j cap plus 3k cap. And now we find out the individual components, I, j, and k. So separating it on that basis, so rearranging the terms, we'll get I cap times, in the first one it's 2, in the second one it's minus 4, in the third one it's plus 3, plus j cap times, in the first term it's 2, in the second term it's plus 2, minus of minus, and then in the third term it's minus 6, plus k cap times, first term is 2, second term is minus 3, third term is plus 3. And therefore, we'll get our vector as 2 minus 4 is minus 2, minus 2 plus 3 is 1. So we have I cap plus, it's not actually plus because we have to find out what is inside first. 2 plus 2 is 4, 4 minus 6 is minus 2. So it'll be I cap minus 2j cap. And then 2 minus 3 plus 3 is equal to 0, so plus 2k cap. This is the value of 2 into vector A minus vector B plus 3 into vector C. Now we need to find out its modulus so that we can find out the unit vector. So modulus 2A minus B plus 3C whole modulus. So that gives you 1 square plus minus 2 the whole square plus 2 the whole square under root. So that means 1 plus 4 plus 4 under root. That gives you under root 9, which is equal to 3. And now since we got the value of the modulus, let's find out the unit vector. Unit vector parallel to 2A minus B plus 3C. Now that will be equal to I cap minus 2j cap plus 2k cap divided by 3, which will be equal to 1 by 3 I cap minus 2 by 3 j cap plus 2 by 3 k cap. Now let's find out the required vector. So the required vector is equal to magnitude of vector times the unit vector. And since our required vector is parallel to 2A minus B plus 3C, it has the unit vector of 2A minus B plus 3C. And its magnitude, according to the question, is 6. So here it is, our required vector, 6 times 1 by 3I minus 2 by 3J plus 2 by 3K. And 3 divides 6 2 times, so that gives you 2I cap minus 4j cap plus 4k cap. This is our required vector. Let's move on to the final question. Find the position vector of a point R, which divides the line joining 2 points P and Q, whose position vectors are given below, externally in the ratio 1:2. Also show that P is the midpoint of the line segment RQ. This question has 2 parts. Let's tackle the first part. Now, the position vectors of P and Q are given. So the vector OP, position vector of P, that is 2A bar plus B bar, 2 into vector A plus vector B. And for Q, the position vector is vector OQ, that is equal to vector A minus 3 vector B. Again, we don't know what A and B are here. And so to better understand this question, let's draw a diagram for the same question. So over here we have a line, and then we have OQ. So that means this is the point Q, and this is the point P. And now we have to find the coordinates of an external point, vector OR, that is position vector of the point R, such that the divided ratio is 1, which is the distance of OP and OQ, is to 2. That is the whole distance. So this is the external ratio given. So this point divides the line externally. It basically extends the line in such a way that we get the external ratio 1:2. And by the way, M is 1 and N is 2. So the value of M is 1, the value of M is 2. So M is to N is equal to 1:2. So how do we solve this question? We solve this question using the section formula. And the section formula here is the vector OR can be written as M times vector OQ minus N times vector OP divided by M minus N. And the reason why it's minus is because the point which is dividing the line is outside the line. It's an external point. So let's find the vector OR. So vector OR is M is 1 times vector OQ is a vector A minus 3 vector B minus of N is 2 times vector OP, that is 2 into vector A plus vector B divided by M minus N. So that is 1 minus 2. So let's simplify this. So we get vector A minus 3 vector B minus 4 vector A minus 2 vector B. The whole divided by 1 minus 2 is minus 1. So basically it boils down to minus of vector A minus 4 vector A minus 3 vector B minus 2 vector B. 1 minus 4 is minus 3, so minus of minus 3 vector A minus 3 minus 2 gives you minus 5, so minus 5 vector B. And since there's a minus on the outside, it cancels out, the minus is in, so we get 3 into vector A plus 5 into vector B as the position vector of the point that divides the line externally, which is vector OR. Now the next question. We need to show that P is the midpoint of the line segment RQ. So if P is the midpoint of line segment RQ, then the vector OP can be written as the sum of the vectors OR and OQ divided by 2, half of the sum of the vectors OR and OQ. This is by using the midpoint formula. Now we need to find out which of these is true. Now we need to find out whether this is true. So vector OP, as given in the question, has the value 2 into vector A plus vector B. Now let's tackle the right-hand side. Vector OR plus vector OQ divided by 2. So that will be equal to 5 into vector A plus, no, it's actually 3 into vector A plus 5 into vector B plus vector A minus 3 vector B divided by 2. So 3 into vector A plus vector A, that gives 4 into vector A. 5 into vector B minus 3 into vector B gives you 2 into vector B, whole divided by 2. And we can take 2 common, so 2 times 2 into vector A plus vector B divided by 2. 2 gets cancelled, so we get 2 into vector A plus vector B. And since that is equal to the LHS, we have proved that P is the midpoint of the line RQ. And we proved it using the midpoint formula. So that is the way to do it. We need to find out this using the section formula, the point R, and then using the coordinates of R, using the position vector of R and Q, we need to find out that P is their midpoint. And we did the second part using the midpoint formula. And that concludes this episode of CBSE board exam. Now remember, we have a whole lot of videos on it, whole different chapters about their questions in CBSE board exam and how we tackle them easily. So if you want to stay connected with us, then please don't forget to like the video, share it to others, and also subscribe to our channel. You can also hit our notifications button for getting access to our latest content, such as learner words, mind maps, NEET preparation, memory hacks, etc. We also have a whole series on matrix and a special video on logarithms, so don't forget to watch that out. And until the next episode, take care, stay safe, bye-bye for now.